Hey, did you know that vinegar is also known as ethanoic acid?
I always knew it as acetic acid. Are you sure?
Actually, both of them are correct. To avoid such confusion between names of organic compounds, a standardized naming convention is followed all over the world. You will learn more about this system of nomenclature in this lesson. This lesson is about functional groups and the IoPAC system of nomenclature. By the end of this lesson, you will be able to define functional groups, classify carbon compounds based on the functional group present in a particular compound, explain the procedure of naming carbon compounds using the IoPAC system. About 10 million organic compounds are known to exist till date. Fortunately, organic compounds consist of a few similar parts combined in different ways. This helps us predict how a compound that we have never seen before may react by comparing how other compounds containing the same parts are known to react. These parts of organic compounds are called functional groups. Functional groups are specific atoms, ions, or groups of atoms that have consistent properties. A functional group makes up part of a larger molecule. In organic chemistry, apart from hydrocarbons, there are other molecules where carbon forms bonds with other elements, such as halogens, oxygen, nitrogen, and sulfur. A hydrocarbon chain contains one or more atoms of elements other than carbon and hydrogen. These additional atoms are called heteroatoms. Therefore, a heteroatom is an atom other than carbon or hydrogen present in a hydrocarbon chain. Heteroatoms have characteristic properties that are independent of the length and nature of the carbon chain. Hence, these heteroatoms are also called functional groups. Compounds that have the same functional group undergo similar reactions. For example, when a piece of sodium metal is added to alcohol, it reacts vigorously and liberates hydrogen gas. This property is independent of the number of carbon atoms in alcohol, but is dependent on the functional group OH. A large number of organic compounds, remembering each individual name is next to impossible. This is why a rational system of naming carbon compounds was developed. It was modified by the International Union of Pure and Applied Chemistry, IoPAC, and is followed all over the world. According to the IoPAC system of nomenclature, the name of an organic compound consists of a root word, a suffix, and a prefix. The root word indicates the number of carbon atoms in the basic skeleton. The chains that contain up to 4 carbon atoms have special root words which are based on their common name. For chains that have more than 5 carbon atoms, Greek number roots are used as the root words. For instance, when there is 1 carbon atom in the compound, the root word is meth. In case of 2 carbon atoms, the root word to be used is eth. Similarly, if the compound contains 10 atoms of carbon, the root word is dec. The phrase which indicates the nature of a functional group in the molecule is called the suffix. There can be 2 types of suffixes, primary and secondary. A primary suffix is added to the root word to indicate saturation or unsaturation in the carbon chain. Hydrocarbons that contain double and triple bonds are known as unsaturated hydrocarbons. For saturated hydrocarbons, the primary suffix ane should be added. Consider a molecule that has 2 carbon atoms. The root word should be eth. As it is a saturated hydrocarbon, the primary suffix ane should be added to the root word. Therefore, the name of the molecule is ethane. Hydrocarbons containing double bonds are known as alkenes. For such hydrocarbons, the primary suffix "ene" should be added to the root word. For example, for a molecule that has 2 carbon atoms, add the root word "eth". If there is a double bond between the carbon atoms, add the primary suffix "ene". Hence, the name of the molecule is ethene. Hydrocarbons that contain a triple bond between carbon atoms are known as alkynes, and for naming such hydrocarbons, the primary suffix "ine" should be added. For instance, a molecule that has 3 carbon atoms will have prop as the root word. If there is a triple bond between the 2 carbon atoms, add the primary suffix "ine". The molecule is therefore named propyne. A secondary suffix indicates the functional group present in the carbon compound. The terminal "e" of the primary suffix is replaced by the second suffix. The table shows examples of secondary suffixes. For example, a molecule of ethyl alcohol contains 2 carbon atoms, so the root word is eth. It is saturated, so the primary suffix should be "ane". But as there is a functional group OH in the molecule, remove the E from the name of the molecule and add the secondary suffix "ol". Therefore, the IuPAC name of ethyl alcohol is ethanol. Using the same set of rules, let's try to find out the IuPAC name of aldehyde. Take the example of a molecule of aldehyde. It contains 3 carbon atoms, so the root word should be prop. There are no double bonds between the carbon atoms in an aldehyde molecule. The aldehyde molecule is saturated, so the primary suffix should be "ane". However, the molecule contains a functional group CHO, so a secondary suffix needs to be included in the name. Remove the E from alkane and add the suffix "al". Therefore, the IuPAC name of the given molecule is propanal. Similarly, let's try to compute the IuPAC name of ketone. In a given ketone molecule, there are 3 carbon atoms. Hence, the root word should be prop, and as it is saturated, the primary suffix should be "ane". However, there is a functional group C double bond O, so you must remove the E from the alkane and add the secondary suffix "one". Hence, the IuPAC name of the molecule is propanone. Now, let's write the IuPAC name of carboxylic acid. As per the given table, the molecule contains 3 carbon atoms. Therefore, the root word should be prop, and as it is saturated, the primary suffix should be "ane". However, there is a functional group COOH, which means you need to use a secondary suffix. Remove the E from alkane and add the secondary suffix oic acid. Therefore, the IuPAC name is propanoic acid. The parts of the name that precede the root word are called prefixes. For example, in the compound cyclobutane, cyclo is the prefix that indicates the alicyclic nature of the compounds. If the compound is not alicyclic, the prefix is absent. Let's look at some examples of IuPAC nomenclature for straight-chain saturated hydrocarbons. The compound CH4 contains 1 carbon atom, so the suffix is meth. It is a saturated hydrocarbon, that is, the carbon atom is bound to 4 hydrogen atoms by a single bond. There are no double or triple bonds. Hence, this compound is an alkane. The IuPAC name is a combination of meth and ane, which becomes methane. C2H6 contains 2 carbon atoms. Hence the suffix is eth. The carbon atoms are saturated with each having 4 bonds attached to different atoms. Thus, it is an alkane. The IuPAC name is ethane, which is a combination of eth and ane. The compound C3H8 contains 3 carbon atoms. Hence the suffix is prop. The carbon atoms are saturated. Each carbon atom has 4 bonds attached to different atoms. Thus, it is an alkane. The IuPAC name is a combination of prop and ane, making it propane. The compound C4H10 has 4 carbon atoms, so its suffix is bute. The carbon atoms are saturated, with each having 4 bonds attached to different atoms. Thus, it is an alkane. The IuPAC name butane is a combination of bute and ane. Since C5H12 has 5 carbon atoms, its suffix is pent. The carbon atoms are saturated with each having 4 bonds attached to different atoms. So, it is an alkane. The IuPAC name is a combination of pent and ane, pentane.